Thank you, everyone. My name's Kieran Jacobsen. I am really excited to be back here again this year. I work for a company called Redify down in Melbourne. We do cloud, Windows consulting, a bunch of other development stuff. Basically, the aim of my presentation today is just to show you what you can do with the Hak5 rubber ducky. It's a human interface device that basically allows us to do some really cool automation. So what can it do? What's the best way to describe the Hak5 ducky? Pretty much imagine a keyboard that you've stuck a processor on. It's a very small microprocessor, 60 megahertz. It can be controlled by a scripting language called DuckScript. And you can do anything that you can do on a keyboard. If you've got any attacks that you know that you can sit there and type into a user's PC, then the ducky can do it for you at 1,000 words per minute. So much faster than you can type. Payloads can be pretty much anything. There's payloads to extract data, change settings, rickroll, install malware, all sorts of things. And you can just customize it really simply and easily. It's effective against pretty much all modern operating systems. If it supports a USB keyboard, then it can be attacked by the rubber ducky. The rubber ducky is just what's called a HID device, as I said earlier. Windows, Linux, OS X, and even Android are now really great targets for this sort of thing. Android's a great one because you can do things like trying to brute force the pin code lock screens, and it can just sit there and try each combination until you get in. What sets the ducky apart from a lot of the other sort of similar devices in this sort of programmable HID, this sort of space, is that the ducky doesn't store its payloads sort of in a protected state. You just have to put them onto a micro SD card in the ducky. A lot of other devices you need to have a serial cable and you need to sort of write them in via the firmware interface. With the ducky you just write the script, put it on SD card and you're ready to go. There's a bunch of different firmware options now available for the ducky, and they take the standard firmware image that Hak5 made and just sort of move it to another level. These include ones that allow multiple payloads. So you might execute a payload against Macs if caps lock is enabled. You might execute payloads against Windows if numlock is enabled. And that's today how I'm doing a lot of these demos, so I don't have to keep trying to change out my SD cards all the time. Some of the firmware images also include the ability to access that SD card from the victim's PC. By default with the stock ROM, you can't access that SD card. So you might have a 256 or a 1 gig card sitting in that ducky, but you can't actually use it for storage. You can't extract documents off a victim's PC and store it on the SD card. You've got to find some other way of getting the data off the machine. With the more advanced firmware images, you can access that SD card. All of these advanced firmware images do come at a bit of a cost, and that is your payloads have to be smaller. The standard firmware image, you can have about a 20 or 30K payload, and that does allow you to do a lot of devious things. With the advanced firmware that I'm doing today, I'm limited to 2 kilobytes. So it needs to be really short and really effective payloads. You can still do quite a lot of damage, but you've got to do it in a lot less keystrokes. So how do you come up with a payload? Well, I suppose the first step is working out what you want to do. How am I going to type it in? Am I going to hit Windows key R and then type this and hit enter? Am I going to start going up and down through menu prompts? Once you've come up with that plan, you need to then convert that into what's called the DuckScript. DuckScript is just a sort of way of driving the keyboard. And it has a bunch of commands like GUI, which is for the Windows key, delay, which allows you to wait for a few seconds while things are happening, hitting the enter key, toggling the caps lock, numlock, and so forth. You can even move with left and right keys and things like that. It's all a really self-explanatory scripting language. Once you've written that script, you then need to encode it into a binary format so that the Ducky processor can handle it. There's a number of different ways of doing this. Typically, you use what's called the encoder.jar file, which means, unfortunately, you need to have Java running, and that's a bit of a pain in the ass. Once you've got that binary file, you put it onto the SD card, and then you've got to just somehow get the Ducky into your victim's PC. And that's sort of where a bit of social engineering might come into play, or just a bit of luck. Some people will just leave duckies lying around and wait for victims to just pick them up. and plug them into their computers. And that's a fairly effective way of doing it, but it can also be a pretty costly way of trying to get in an organisation. So I'm just going to walk through the first of two scripts that I want to show you today. This is sort of your standard hello world script. So what we'll do, the start of every script, we need to wait. We need to wait for the operating system to go ahead and start whatever drivers it needs to. It might need to initiate keyboard drivers, it might need to install drivers. So we need to give the operating system a bit of time to do that. And that's why we have that delay of 500 milliseconds there. And that's usually enough time for a Windows PC to start accepting the rubber ducky. Next, we're going to type GUI R, and the GUI keyboard, the GUI command in Ducky script is very much, it's your Windows key or your Mac command key. So GUI key R is Windows key R. That's bringing up our run dialog box. We're then going to type in Notepad. So string Notepad is essentially, I want to type this string in. So I'm going to type in Notepad into that open dialog box, and then I'm going to hit the Enter key. I'm then going to wait a little bit for Notepad to open, and then I'm going to start typing some more text in. So I'm going to type just some text from the CrikeyCon website itself. And that's it. That's your first Hello World script. Now, let's try this as a demo. So I'm just going to turn on the on-screen keyboard so you can start to see what's happening. One thing I need to do is make sure that numlock is enabled. So as I said earlier, I'm running a slightly more advanced firmware. One payload will execute if numlock is enabled. The second payload will execute if caps lock is enabled. Nothing happens if none of these are enabled, which is kind of handy when you're testing so you don't end up rickrolling yourself like Ash just did earlier. So now that numlock's enabled, I'm just going to get the rubber ducky, and it's just this little tiny USB key, and hopefully it all works. Unfortunately, it's hidden behind the keyboard. So as you can see there, in a fairly quick amount of time, I've just written that text in. Very, very quick and effective attack. And that's just simply a hello world example. So let's take a look at a bit more of an advanced script. This script is a bit smaller than the last one, but it's doing a bit more. Once again, I've got that wait of 500 milliseconds. Just going to wait for the operating system to detect us. The next command might seem a little bit strange for most people. And the reason for that is, as I said, caps lock is enabled for the second payload to run. Before I start to type anything, I want to turn caps lock back off. So hence I'm going to use the caps lock command to switch caps lock back off. And that just toggles it. I know it was on, I'll toggle it off. Once I've done that, I'm going to do the same few steps as I did last time. I'm going to hit the Windows key, and then R key, and bring up the run dialog box. This time, instead of Notepad, I'm going to start typing in a PowerShell command that I want to run. So I'm going to run PowerShell. I'm going to tell it, run with an execution policy of unrestricted, so I can run any scripts. I'm then going to say, hey, I want this window to be hidden. I don't want the user to see it. And then I'm saying, hey, I want you to run this specific set of commands. And the specific set of commands are, roughly put, find the file system called Ducky. What I've done is I've named the SD card's file system as Ducky, so I can easily find it no matter what the drive letter is. Once I've found that file system, I want to import what's called the PowerCat module. PowerCat is a really cool new thing that's come out about 3 or 4 months ago. It is a almost like-for-like feature, almost feature-complete version of Netcat, but written entirely in PowerShell. You don't need to worry about antivirus products picking it up or anything like that. It's all in PowerShell. It does most of the features that the classic Netcat command does as well. So once we've imported PowerCat, I'm then going to tell PowerCat to connect to an IP address and to that port. I'm also telling it the -EP parameter. -EP, instead of opening a normal command prompt, I'm going to end up with a PowerShell session connecting through. So on my Kali Linux box, I should be able to start typing PowerShell commands into the prompt, and I'll be executing back on the victim's PC. So this time, I need to make sure that caps lock is enabled, so I'll just switch to the on-screen keyboard. And I'll just switch off and unlock. Right, so now I'm just going to connect the Ducky up again. Now it looks like not that much has happened. We've sort of seen a PowerShell window open and then it's closed away again, but that's the hidden window opening and closing. As we can see here, where is my? I'll just have to close the on-screen keyboard. As you can see here, we now have a PowerShell console showing up in my Kali box. So if I type in hostname, that's the hostname of the Surface Pro that I'm running on directly. I can then type in any commands like get help, and I'm now using PowerShell. So I'm now using PowerShell via PowerCat on the victim's PC, all through a reverse session. Do we have time for one more demo? Right. Hopefully this one works. So changing the SD card is a fairly simple process. You just need to unconnect the hook, and then just slide the other SD card in. If it works. This time it's another numlock enabled one, so we'll just have to open the on-screen keyboard again. Right, so this time this is a little Rickroll payload that we've got. It's a multi-page sort of step one. The first time it's just simply going off and downloading a Rickroll image from the internet. It's then going to wait a little bit of time, and then it's going to open up that image and set it as a desktop background. And it looks like it's failed. That's all right. Rightio. So, before I ask if there's any questions, there's a bunch of useful links out on the internet to do with the Hak5 Ducky. First, if you've got any questions, come and see me afterwards in the events area. I'm happy to show you some more payloads. I've got some things to do with Mimikatz and keyloggers written in PowerShell and a few other things as well. I'm on Twitter at Jacobsen. I'm going to be putting all of the code both in its plain text and in its encoded format up on my website, which is poshsecurity.com. If you want to get your own Hak5 Ducky, go to the Hak5 store. The Hak5 team have some really good documentation on both their forums and the project wiki. They've got links to some really cool ideas for payloads and various other sort of useful tools. The top right link, the Ducky Decode project, is probably the most useful, and it's definitely the most extensive project out there at the moment. They have documentation on all of the Ducky script. There's multiple firmware images available there. They have a lot of documentation on the differences between each firmware image. They even have information on flashing those different firmware images onto your Ducky as well. The next two sites, the Ducky Toolkit and the Simple Ducky Payload Generator, they're a bunch of sites that are aimed at helping you develop your own scripts. And there is some advantages and disadvantages to using their automated process. The Ducky Toolkit page, its payloads can be very large. They can be 10 and 15 kilobytes, which means you need to stick to that more default firmware. And it can be a bit difficult. The Ducky Toolkit website also has a web version of the encoder, so you don't need to have the Java version of the encoder if you don't want to. Finally, there's a link to PowerCat excuse me, PowerCat is a really good resource. I really recommend everybody takes a look at it. It's got a few different contributors. They're all trying to make it feature complete and work through a lot of the bugs. And it's also still it's a bit experimental still, but it's pretty bug free at the moment.
All right, Kieran. Big round for Kieran. Yeah. Now, Kieran, I noticed that you described a 5-step process with the final step being insert rubber ducky into victim, and I thank you very much for not providing us with a video link for that particular step. Does anyone have any questions for Kieran? While we got him here, can we get a microphone and a stubby cooler over to this man over here in the grey hoodie? Nice throw.
Why would you choose the advanced payload or the advanced firmware over the default one?
Especially if you're using it yourself, you might be sort of wandering through the office and you want to try, of a network that you're trying to test, or maybe it's your own network and you just want to try and quickly see how far you can go. You might want to try and run multiple payloads. The advantage of being able to say, I want to run payload 1 using numlock on this victim's PC, then unplug and then run over to another PC and run a different payload without having to do, as you saw, that process of changing the SD card can be a bit tedious. Most of the time it's fairly quick, but it is a bit fiddly. So you might want to sort of try and keep that a bit more simple. The other thing is that because it doesn't do anything when somebody plugs it in, it's a bit more safe to leave around the office. I left this on the desk all week and thankfully no one just picked it up and put it into their PC. And even if they had, without having numlock or caps lock enabled, it was pretty safe to say that they weren't going to hurt themselves. Having an SD, being able to read the SD card, especially if you put a bigger SD card on there, means you can copy files off the victim's PC. The reason that the Rickroll failed was because the internet I've got here is a bit flaky, so it was trying to get off the internet, whereas the PowerCat one was all on the SD card, so I didn't have internet access. And that can be, if you're in a sort of more restricted environment, that can be easier as well.
Do we have any other questions before we get on to our next presentation? There we go. Stubby cooler over there, please.
Coming.
Oh, he's on fire. Come on.
So interested to hear your thoughts on mitigations for this type of attack. Obviously we can't just go around blocking everyone from installing USB input devices like keyboards in their organisations, but is there anything out there in terms of, say, a common list of USB vendor IDs for these types of projects that organisations could look to filter? And in terms of, say, PowerShell, have you got any other recommendations for mitigating that besides, say, enforcing signing on PowerShell applets within organisations?
So the big drawback is you can't just simply limit a set of USB IDs with these. It's pre-programmable. There is a tool to go and change the IDs. So pretty much every time I do this demo, I'm always redoing that, so I make sure that the drivers are all clean and fresh. So blocking a set of USB IDs isn't really as effective. It's about the fact that you're letting a user connect the keyboard up to the device. It's a hard one to defend against because overall they need to be able to connect keyboards into the device. You might limit them using SD storage, but they can't really stop them plugging in a keyboard. The only really effective way is probably to try and prevent the payloads from running. So if you know the payload might be going off and connecting off to unknown web addresses, maybe locking it down that way. Locking down PowerShell through whatever various means that you want to do, be it whitelisting, blacklisting, whatever you want to do is another option. But then you can always go back and just open Internet Explorer and do it that way. You can go Windows key I Explorer and then just start feeding in commands that way. The user's going to think something's a bit amiss, but you could just go down that path. It's a fairly interesting attack to try and block.
Cheers.